Hello, I welcome you all. The problem reads the car travels along a circular path such that its speed is increased by at equal to 0.5 e to the power t in meters per second squared, where t is in seconds. Determine the magnitudes of its velocity and acceleration after the car has traveled s equal to 18 meters starting from rest. Determine neglect the size of the car. This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. So the basic equations, just a reminder, we have V equal to dSdt, we have A equal to dV dt. From the two equations, we have A ds, V dV. Right, from these equations, we are able to derive the couple of equations depending on the boundary conditions. But we do have a special one when acceleration is constant. T equal to 0, we have additional boundary conditions. From this, we derive the following equation: S is equal to S naught V naught T plus half ACT squared. And we have V equal to V naught plus ACT, and V squared is equal to V naught squared plus 2ACS minus S naught. Okay. So what we have here, so let's imagine this is the point we are looking at. This is the point here, and let's say we have our velocity here, tangential, velocity tangential, like so, and let it come like somewhere there. So we do have our velocity like so, and let's say we have our acceleration, one component in this direction like so, and then the other one, the centripetal one, in that direction like so. So let's call this as AN, this one as AT, T for tangential, N for normal, and then let's call this as our VT. Okay, we call this as our VT. Right. All right. So what do we have? We have AT. We have AT equal to 1.5 e to the power t, and also we do have S equal to 18. Right, I'll go with this equation here, this one, right? So this is A equal to dV dt. Writing this just becomes A dt equal to dV. So integrate on both sides like that. So from 0 to t, from 0 to t, and this one is also V naught is 0, we are starting from rest to V. Then we have a 0.5 e to the power t, integrating from 0 to t, dt equal to 0 to V dV. Right, so this one just becomes a 0.5 e to the power t minus 0.5, right? Then equal to V. Therefore, our V is just going to be equal to 0.5 e to t minus 0.5. Okay, so we need to, the idea here is to find the time. We are looking for the time that we're going to use, because our velocity is a function of time, so is our acceleration, the tangential. Right, so for these ones we need the time, and we can calculate the time by using these particular equations. Okay, so found V This is VT. Right, so found VT. So the idea is we need to find the time. So let's use this equation to find the time. So V is equal to ds dt, and writing this, it just becomes equal to V dt equal to ds. Okay, replacing this, going to have a 0.5. We have a 0.5 e to t minus 0.5 dt integrating from 0 to t equal to 0 to s, and our s is 18 ds. Right, so this just becomes 0.5 e to t minus 0.5 t. We are evaluating this from 0 to t equal to 18. Therefore, we'll have 0.5 e to t minus 0.5 t, then minus 0.5 equal to 18. Factoring this out, it just becomes e to t minus t equal to 18 divided by 0.5 plus 1, right? Ideally it was like this. Initially it was like this. Minus 1 equal to 18 divided by 0.5. So we can take this, the other side, and take this. Okay, so it becomes plus 1. Okay, and therefore this just becomes 36 plus 1, which is 37. So this is equal to 37. But we can write this also like this. Just becomes minus 37 equal to 0. So let's say we have this function of t, which we are going to solve using numerical techniques. T minus 37 equal to 0. So we're going to use the trial and error. You can use whatever method. Trial and error method is a numerical technique, and ideally what we are doing is we are trying to find values of t that will give us a negative and positive, and then we begin doing the iteration so that we get closer to 0, because 0 is the analytical. When we get to 0, that's an analytical solution, but we want to get as close as possible to 0. Okay, and our domain, our t, will just be equal to greater than 0, because t cannot be negative. So let's start doing the iteration quickly. There we go, something like that. So we have t here. We have t, then we have the function of t. So with t equal to 0, this becomes 1 to 0. So this just becomes so let me write down in advance the equation here. So e to the power 0. I'm just writing this in advance to 0 minus 37. Okay, so we have a minus 36. Maybe let's go to 2. Okay, so we keep on moving, going up, 2 and 2 there. We have minus 31. Okay, let's go to 8. Okay, 8. We have 2935. Okay, so we know that the solution is somewhere between 2 and 8. Okay, so let's get the average of the two. The average of the 2 plus 8 is 10, divided by 2 is 5. So let's plug in 5. Okay, right, so we have a 10641. So again we go the smallest negative and the smallest positive. 2 and 7, that's 2 and 5, that's 7. Half of that is 3.5. Let's plug it in. So we continue doing this. So we have a minus 7.38. So then this becomes the smallest. That is 8.5, which just becomes a 4.25, right? I think so. I have the formula in my the calculator. So what do we have? We have 5 plus 3.5 divided by 2. That's 4.24.5. So let's plug it in. 4.2.5. Okay. 4.2.5. So this gives us 28.86 positive. So we can move to this, shift to this. So 4.25 plus 3.5 divided by 2. So we have 3.88. Let's plug it in. 3.88. 3.88. So this gives us a 7.54. So again we are moving to these ones. Okay, 3.5 plus 3.88 divided by 2. We have a 3.69. Let's plug it in. That's also that side. So we have a minus 0.65. This is okay. It's becoming smaller, the error. 3.88 plus 3.88 plus that. 3.88 plus 3.69 divided by 2. This is 3.79. Let's see what we have. Say 3.47. Okay, the 2 again. 3.79. 3.79 plus 3.69 divided by 2. 3.74. Let's plug it in. 74. This is 1.36. 1.36. Here again. 3.69. This plus 3.69 divided by 2. 3.72. 3.72. That's a 0.54. 0.54. We have this again. 3.72 plus 3.69. That's 3.71. Let's check out this one. 71. That's a 0.14. Okay. Again, 3.71 plus 3.69 divided by 2. That's 3.7. Okay. 3.7. like so. It becomes minus 0.25. So of course the solution is in between 3.71 and 70, right? Okay. Let's try this one. We see where it is going to lead us. 3.705. Okay, 705. Alright, this gives us a 0 point. This gives us a 0 point. Of course, we had taken these two initially. This gives us a 0.05. Alright, this is the smallest so far. This is the smallest so far, this one. So we can go with this approximate. It's good enough. Yeah, it's good enough. So this is good enough. So we can say our t therefore is approximately equal to 3.0705 seconds. So we use this time now to compute. The value of t. To compute the value of a as well as v. So our at is equal to 0.5 e to the power t, and our vt is equal to 0.5 et minus 1. Alright, so let's find this. So therefore our t at 3.705 will give us, what will it give us? So we have 0.5 times e to the power 3.705. Okay, so this gives us a 20.33, right? And then v of t at 3.705 will give us, let's work it out, that's e to the power 3.705 minus 1, and then times 0.5. So this gives us a 19.83. Alright, so we have an, which is just equal to vt squared divided by rho, and this is equal to 19.83 squared divided by our rho is 30. Therefore our an is just going to be equal to, that's 19.83 squared divided by 30. Okay, so this we get a 13.11. So our acceleration is just going to be equal to at squared plus an squared. Therefore our a is just going to be equal to, so we have 80 is a 20.33 squared plus an is 13.11 squared, square root of that. We have a 24.19, and this is in meters per 19 meters per second squared. And our v is equal to vt, which is equal to 19.83 meters per second. Alright, so these are the final solutions for our problem, and I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.